Hello everyone, today we'll be covering Group 17 of CAIE A-Level Chemistry. This is a part of the AS syllabus, and in today's video we'll be covering the following subtopics: the physical properties down Group 17 and the reactions with thiosulfate, the trend in reactivity down Group 17, thermal stability of hydrogen halides, melting point of hydrogen halides, trend of halides acting as a reducing agent, reaction of NaX with H2SO4 plus observations, disproportionation reaction, for example with chlorine, the chlorination of water, and the test of halides. Let's get to it. We have a lot to cover, so yeah. Anyway, so firstly, let's talk about the physical properties. And for group 17, we normally consider fluorine, chlorine, bromine, iodine. We don't really consider acetylene. So this is gaseous, this is gaseous, this is liquid, and this is solid at room temperature, right? And the appearance is this, we don't really need to know. Pale green gas. So this is pale gas, this is brown liquid, and this is black solid, right? And down group 17, the color becomes darker, as in less paler. And the reason why this is gas, this is liquid, and this is solid is because down group 17, the van der Waals, or induced dipole to dipole forces of attraction, increases, and that is because increasing in number of electrons. Okay, this is something you learned, I don't remember which lesson exactly, but something you learned before, so this is just a recap, right? And that's pretty much it for the physical properties. Oh, okay, one more thing. In gaseous form, I2 gaseous, it is a purple fume or vapor. Everything I just said is important, and it appears in your AS papers and sometime your A2 as well. Okay, let's move on. So the next part is the reactions with thiosulfate. And thiosulfate is S2O3. S2O3 2-. Now this is something from your previous syllabus, but I have seen it being asked once in the later syllabuses, and therefore that is why I'm covering it. And so the thing is, when Cl2 and Br2 can oxidize S2O3 2- to sulfate, whereas for I2, because it is not as strong as an oxidizing agent, I2 oxidizes it to produce S2O3 2- to produce persulfate instead, which is S4O6 2-, right? And the equation for this is Cl2 plus S2O3 2- gives SO4 2- plus 2Cl-. And it's the same equation with Br, and for this it's S2O3 2- plus I2, which would give you S4O6 2- plus 2I-. Okay, the reason why persulfate is produced here is because iodine is not as strong as an oxidizing agent as chlorate and bromine are. Okay, now let's move on to the next. The next point is regarding the trend in reactivity down group 17. Reactivity. So when it comes just like down to the elements or molecules, the simple elements and molecules, what you have to remember mainly for group 2 and 17 is that when group 2 elements or metals react, they give away an electron, whereas for group 17, when they react, they take in an electron, alright? And therefore, for group 2, the easier or the more readily they give off the electron, the more reactive they are. And for group 17, the more readily they take in the electron, the more reactive they are. And that is why for group 17, reactivity decreases down the group. Right, so for fluorine to chlorine to bromine to iodine, right? The reactivity decreases down the group. And the reason for that is because down group, there is an increasing number of principal quantum shells. And more distance between outer shell electron and nucleus, which is basically the atomic radius, and therefore weaker nuclear attraction. You could also refer to the increasing nuclear charge and say that these two, like this, the increasing number of quantum. Oh yeah, and you also have to refer to increasing shielding effect. This is somewhere in between here. I forgot to mention. Apologies. Anyway, you should say that the effect of this and the more distance, it outweighs the effect of increasing nuclear charge, and therefore there's a weakening nuclear effect. And because of this, the ability to get reduced decreases, and therefore the reactivity decreases down the group, right? That is the explanation for why. That is the explanation for the reactivity. Now, that is also a reason for an explanation for the electronegativity. So recall that we learned about electronegativity, and that is, the tendency of something to pull the bond pair of electrons towards itself. So the reason why fluorine is more electronegative is because of all of this. Like, there's lesser shielding effect, and there's a lesser shielding effect, and the bond, like, there's a reduced bond length and all of that, and therefore fluorine attracts the bond pair of electrons towards itself more than chlorine or bromine or iodine, right? Well, in case of, yeah, so fluorine, bromine, iodine, right? That's why electronegativity also decreases down group 17, or generally decreases down all the groups. Okay. Now, when we talk about group 17, we also talk about thermal stability. And the thermal stability of hydrogen halides. Okay. So when you look at the thermal stability, you will see that thermal stability, I think for thermal stability, it decreases down the group. And when you refer to this, the y decreases down the group, you should say that because the strength of the HX bond, where X can be Cl, Br, I, right? The strength of the HX bond decreases and therefore requires lesser energy to break. And that is why the thermal stability of hydrogen halides decreases down the group. But when we talk about the melting point of hydrogen halides down the group, you should know that for hydrogen halides, melting point increases down group, and the reason for that is you should not refer to HX bond here, then it'll be mistaken. But you should not refer to the HX bond here, but for this, what you have to refer to for melting points of simple molecular structures is that increasing number of electrons, therefore increasing IMFs. increasing strength of IMFs or van der Waals forces or induced dipole to dipole, right? However, HF has a much higher melting point, and we learned this in a lesson before as well, and that is because F is electronegative, directly bonded to an H, and therefore there is hydrogen bonding between HF molecules. And here you can refer to that hydrogen bonding is the strongest IMF and requires much more energy to break than relative to the other hydrogen halides. Okay, that is all for the trends in the trends down the group. Okay, and next is an important reaction, and that is between H2SO4 plus NaX. This is a very important reaction, and they ask about it many times, and it comes for a huge number of marks. Okay, this is very important. And over here, X can be Cl, Br, or I. Okay, so the first important thing about this is that H2SO4, it is a strong oxidizing agent. H2SO4, strong oxidizing agent. This is the first key principle of this reaction, that H2SO4 is a strong oxidizing agent. Another key principle of this feature is something that you can sort of correlate with the trends we've learned before, is that for X minus, where X is equal to Cl, Br, or I, right? The reducing power, and recall what is reducing. Reducing means it gives away an electron. So reducing power meaning how likely it is to get oxidized. Again, recall oil rig. Okay, and oxidation is loss of electrons, whereas reducing is gain of electrons. And when something is reducing and something is a reducing agent, it reduces something else and therefore gets oxidized itself, right? And oxidation is when there's a loss of electrons. So the more likely a stronger reducing agent is something that is more likely to give away electrons than gain electrons. Now think about what we talked about earlier. Down the group, it is less likely to gain an electron because of all the shielding effect and blah blah blah. You get me, right? So for X minus, down the group, reducing power increases. Okay. And if you're asked in a question for the reasonings, you could mention what we covered before in this lesson. So this is the second key principle, and these are the two key principles on which this reaction works. Okay, and these are the two key principles you have to keep into mind. So the first is the reaction between NaCl plus H2SO4. Okay, the first reaction, it would give NaHSO4 plus HCl. For those of you who are good at equilibria and acid base, you would notice that this is the type of reaction is an acid base reaction. The reason is because H2SO4 acts as an acid. It donates an H plus to Cl minus, and therefore it donates an electron to Cl minus, right? And Cl minus is a base. It accepts an H plus. So this is an acid-base reaction. However, this reaction does not proceed any further in presence of excess H2SO4, and that is because the Cl minus over here is not a strong enough reducing agent. Okay. Now let's proceed with NaBr plus H2SO4. It would give you the same, right? NaHSO4 plus HBr, right? Now this Br, it does not stay. Like no matter what you do, if you react NaBr with excess H2SO4, this Br will take part in another reaction plus H2SO4 in presence of excess H2SO4, which will give you just bromine Br2 plus for HBr I think it was SO2. No, wait, not SO2. Versus H2O plus SO2. Okay, this is what's given off when NaBr is reacted with NaHSO4. Sometimes, okay, wait, I'll get into the questions later. For now, just know this, okay? This is an acid-base reaction. The first reaction that takes place is acid-base. And the second reaction that takes place is a redox. And the reason why this is a redox is because there's a reduction in oxidation. As you can see, Br minus minus 1 changes to 0, so it gets oxidized, yeah, and this, yeah, and there's reduction as well. Now for the third reaction, NaI plus H2SO4, it would give you NaHSO4 again plus Hi. This Hi again, the I minus is a much stronger reducing agent. It's an acid-base reaction. This gets used up, but in case of Hi, because it's a much stronger reducing agent, three possible reactions can take place. So Hi plus H2SO4, it would give you, first is it's similar to this reaction. So I2 plus H2O plus SO2. That is the first reaction. Okay, just give me a minute. Plus SO2. Or it can give you I2 plus H2O plus hydrogen sulfide H2S, or it can give you I2 plus H2O plus S, just sulfur alone. Okay, and the reason why this is produced is because this and this is produced in case of Hi and not with HBr is because I minus stronger reducing agent. Okay, now that's a very important reaction. Now, sometimes in questions you may be asked for the first part. The first thing that you could be asked for is why, when you react with, like, first they'll give you a question for reaction between NaCl and NaCl and H2SO4, and you'll get an HBr, right, which is a white fume, and sorry, not HBr, you'll get HCl, which is a white fume, and next they might ask why you cannot get an HBr or Hi if you react NaI or NaBr with excess H2SO4. In such questions, you have to write with HBr or Hi gets readily oxidized, like not oxidized, sorry, readily reacts with, okay, wait, you can write oxidized, yeah, because it gets oxidized, right? But if you write oxidized, make sure you mention what's specific, so Br minus or I minus gets readily oxidized or reacts with H2SO4, which is in excess. Okay, so that's one type of question that can come. Another type of question that can come is that why? Like, why for NaCl the reaction does not proceed further, but for NaBr and NaI it does. Over there you have to refer to the strength of a strength as an oxidizing agent and reducing agent. So first you always have to refer to that H2SO4 is strong oxidizing agent, right? But then you have to give reference to X minus, right? And then you have to say that X minus, like I minus, is a stronger reducing agent than X minus, therefore can reduce H2SO4, and so on. Like, you get the idea, right? And the third type of question they can ask, it's very, by now it's a characteristic of chemistry, and that is observations of the reactions, okay? Now, for observations, I'm gonna have to like scroll back here, okay, I hope you don't mind. So for observations, for the first reaction, because HCl is produced, there's, wait, I'll just start observations. Okay, no, wait, let's make this a bit more clear. Erase that and erase that. So for observations, for HCl is white fumes or gas, or you could also go for steamy, misty fumes, right? And for HBr, also again, it's white fumes, but because HBr is readily oxidized with H2SO4, what you would observe in this case is brown gas, right? Because this is given off brown gas. And then in case of NaI, what you would get is, so the Hi is a white fume, but we cannot write that because Hi is readily oxidized. And so the first is purple fumes, because I2G is purple, what we learned earlier this lesson, purple gas or fumes. And you can also get, well, SO2 does not have anything distinct about it in our syllabus. H2S has a rotten egg smell. H2S, and sulfur is yellow solid, which is sulfur. Now these are the characteristic observations of the reaction. Like, I didn't make it specific, but these are the characteristic observations that you must know in case it is asked. Okay, they can twist their ways, they can twist the ways they ask the questions, but you must know what is characteristic for each of these reactions. And this is the most important part of the group 17 lesson. I suggest you note this down somewhere. Okay. Anyway, we'll move on to the next part of this lesson, which is, oh, pardon, that was unintentional, which is disproportionation reaction. Right, disproportionation. And in disproportionation, we just use the example chlorine. Okay, what disproportionation is basically the type of reaction in which species, well, one species is both oxidized plus reduced in same reaction. Now you may be asking, like, what is the difference between disproportionation and redox in both ways? There's an oxidation and reduction happening, but for redox, the oxidation and reduction happens of two different species, whereas for disproportionation, it's for only one species. So let's take an example, HBr plus H2SO4, which gives, right, we just did it, right, Br2 plus H2O plus SO2, right? So in this case, Br minus becomes 0, so this gets oxidized, whereas sulfur gets reduced instead. Or does it get oxidized? I'm not sure. Okay, yeah, sulfur gets reduced to, so from here it's, so over here it's plus 6. Oh, pardon that, just give me a minute. Over here it's plus 6, and it gets reduced to plus 4. So you see that oxidation and reduction is happening to different species, but for disproportionation, it happens to one species or the same species. So the example is using chlorine. Now, even though we have examples, there's two differences. The first reaction is with cold alkali, i.e. NaOH. This is usually at around 15 degrees Celsius, and the second is with hot alkali, i.e. NaOH. And this is approximately around 65 to 70 degrees Celsius, if I'm not mistaken. Okay. And the example with with cold alkali is Cl2 plus NaOH gives you, if I'm not mistaken, it gives you NaCl plus NaClO plus H2O, right? And if you balance this equation out, there's 2 NaOH here, 2 Na, 2 Na, right? This is the balanced equation, okay? And you see here that the chlorine itself, which is in 0 state, gets oxidized to plus 1 and gets reduced to over here, which is plus 1, this minus 2 is plus 1, so it becomes, wait, hold up, wait, give me a minute. Okay, so over here it's plus 1, right? And then minus, oh, sorry, sorry, in this case, over here, it becomes minus 1, and in this case, it becomes plus 1, right? Because Na is plus, and this is minus 2, so yeah, this becomes plus 1, this becomes minus 1. You see that over here, chlorine gets reduced, and at the same time, chlorine gets oxidized. This is a disproportionation reaction. And in case of hot alkali, i.e. NaOH, Cl2 plus NaOH gives you NaCl again, plus NaClO3 plus H2O. That's what you get. And in this case, the oxidation state of Cl is higher, is because it's at a higher temperature, right? And let's check. Wait, let me balance this equation out first. This will be 3Cl. There's 5 and 1, so there's 6. 5 and 1, there's 6. And there's 3 here, right? 6. 6, yeah. Okay, so this is the balance equation. And the way to balance this properly is by ionic balancing and half equations. And we'll learn that in another chapter. But for now, usually for this, to balance this equation with hot alkali, I recommend that the students they learn the balance equation or the balance form of this, because it becomes easier and less time consuming to balance this equation out, and it comes in multiple choice papers as well, which is why it's better not to invest too much time into just balancing an equation to get your answers. So it's better to by heart the balance form, or if you don't want to, you can like spend your time or invest your time if you're confident enough in your papers. Anyway, see, in this case there's a 0 and it gets reduced first, so there's a reduction, gets reduced, and in this case plus, so minus 6 plus 1, so minus 5, so there's plus 5, and it gets oxidized. And that is why these are known as disproportionation reactions. Okay, and NaClO, this is more of a practical example. NaClO is better known as bleach, and we know what bleach is used for, right? It's used in cleaning, disinfecting, etc. That's what bleach is used in, right? That's what NaClO is. It's bleach. And there's also an explanation in your textbook on how like bleaching changes the color or gets rid of stains, but that is not really in your syllabus, so you don't really need to know. However, if you do, like if you are interested in learning as to how it does that, I suggest you check out a YouTube video that explains it well. Anyway, we'll move on to the next part, which is, oh wait, one more thing that I had to mention, another practical example. NaClO3 is used as a weed killer in agriculture. Okay, NaClO3. There's no name given for this in your syllabus. Anyway, let's move on to the next, which is the chlorination of water. And this is something that you learn in your IGCSE years. Now all you have to do, the only thing that's new in like the AS level is that there's an equation that's present. So H2O plus Cl2 gives you HCl plus HClO. That is literally it for that's all there is for the chlorination of water. That this is hydrogen chloride and this is hydrogen chloride or hydrochloric acid, if I'm not mistaken. That's the chlorination process. And what does chlorination do? It disinfects water. In essence, water. In essence, it kills the bacteria or pathogens that may be present in water. Okay. Now the last part of this lesson is something from your IGCSE years again. It was something that you learned for paper 6, if I'm not mistaken, or paper 5, paper 6, the one that's for alternative to practical, yeah? And that is tests for halides, yeah? So for the halides, there's Cl minus, and there's Br minus, and then there is I minus, right? And the reaction is with Ag plus, or better known as AgNO3, silver nitrate. Okay, then the reaction with dilute NH3, and the reaction with concentrated NH3. 3. So for silver, for Cl minus, whenever Cl minus is involved and reacts with AgNO3 or Ag plus, uh, the result is a white precipitate, right? And when you dissolve this white precipitate, when you react this white precipitate and dilute at Cl, this precipitate dissolves, right? Or it is the same, like if it dissolves in dilute, it will also do the same for concentrated and NH3 or ammonia. For Br minus, a cream precipitate is obtained, PBT, which does not dissolve in dilute NH3, but it dissolves in concentrated NH3. And for I minus, you get a yellow precipitate, which is really nice to look at. So I suggest you ask your teacher to do a test for the I minus halide, which does not dissolve in either. Okay, it does not dissolve in either. It's the same for concentrated NH3. And the reaction for the dissolving in NH3 is so AgX plus NH3. I believe it's 2NH3 is AgX NH3 2. That's what the equation is. So for instance, if X is equal to Cl, then it'd be AgCl plus 2NH3, which would give you AgCl NH3 2. Okay, and this is the general equation. Oh wait, apologies. This is the general equation. I hope you understood. If you do have any doubts, please leave them in the comment section below. Again, the most important part of this lesson is the reaction with H2SO4 and the explanation as to why. And that comes for the most marks. If you did enjoy the video and did understand, or if I helped you in any way, please consider leaving a like and subscribing to our channel.